Have you ever wondered what might be hiding on the side of the moon that Earth never sees? What if a mission designed to prepare humanity's return to the moon ended up revealing something scientists were not expecting at all? Because according to reports from the Artemis program, the far side of the moon is giving researchers new mysteries to investigate. And some of those discoveries are raising questions that nobody thought they would be asking this soon. For decades, the moon seemed familiar. Humans landed there more than 50 years ago. Thousands of photographs have been taken, countless missions have mapped its surface. Many people assumed that the moon was a world with few surprises left to offer. But that assumption may have been wrong. As NASA prepared for a new era of lunar exploration through the Artemis program, scientists hoped to learn more about the moon than ever before. The goal was not simply to visit. The goal was to understand, to study, to prepare for a future where humans could live and work near the lunar surface for extended periods of time. And that is where Artemis II enters the story. Unlike the Apollo missions of the past, Artemis II represents the beginning of a much larger vision, a vision that includes permanent lunar exploration, advanced scientific research, and eventually missions to Mars. The crew of Artemis II is expected to travel farther from Earth than any humans have traveled in more than half a century. Their mission is designed to test systems, gather data, and pave the way for future landings. But as preparations continued and researchers examined information gathered through modern lunar studies, attention became focused on a region that has fascinated people for generations: the far side of the moon. Many people call it the dark side of the moon. The name sounds mysterious, almost ominous, but the reality is slightly different. The far side is not permanently dark. It receives sunlight just like the side facing Earth. The reason it remains hidden is because the moon is tidally locked to our planet. It rotates at exactly the same rate that it orbits Earth. As a result, one hemisphere always faces us. The other remains out of view. For most of human history, nobody knew what that hidden side looked like. No telescope could reveal it. No observer on Earth could see it. The far side remained one of the greatest unknown regions in our part of the solar system. Then, in 1959, everything changed. A Soviet spacecraft called Luna 3 captured the first images of the far side. The photographs shocked scientists. The hidden hemisphere looked dramatically different from the side facing Earth. The familiar dark plains seen from Earth were largely missing. Instead, enormous cratered landscapes stretched across the surface. Ancient scars covered the terrain. The moon suddenly became far more complex than anyone expected. Over the decades, more spacecraft visited. Better cameras arrived. Detailed maps were created. Yet the far side continued to raise questions. Why was it so different? Why did its geology appear unusual? Why did some regions contain features that researchers still struggle to fully explain? Those mysteries have only become more important in the Artemis era. Modern instruments can see details that previous generations could never observe. They can measure temperature variations. They can study mineral composition. They can examine subsurface structures. And what they are finding is transforming how scientists think about lunar history. One of the most intriguing regions lies within a gigantic structure known as the South Pole Aitken Basin. This enormous impact basin is one of the largest known craters in the entire solar system. It stretches roughly 1,500 miles across the lunar surface. To understand how large that is, imagine a crater spanning a distance greater than many states across the United States. The collision that created it occurred billions of years ago. The impact was so powerful that it permanently altered the moon. Researchers believe it may have excavated material from deep beneath the lunar crust. In other words, this basin could contain clues about parts of the moon that would otherwise remain hidden forever. That alone makes it one of the most scientifically valuable locations in the solar system. But recent studies have revealed something even more interesting. Certain measurements suggest unusual concentrations of material beneath portions of the basin. Material that appears denser than scientists expected. Material that does not perfectly match existing models. Researchers are still debating exactly what it is. Some believe it may be remnants of an ancient asteroid that struck the moon billions of years ago. Others suggest it could be evidence of processes that occurred deep within the moon during its early formation. Whatever the explanation turns out to be, one thing is clear. There are still major mysteries buried beneath the lunar surface, and Artemis-era exploration is bringing those mysteries into sharper focus than ever before. The timing could not be more important. NASA's long-term plans place tremendous emphasis on the lunar South Pole. Unlike many other regions, certain craters near the poles contain areas that remain in permanent shadow. Some of these locations have not seen sunlight for billions of years. Temperatures there can become unbelievably cold, so cold that scientists believe water ice may have survived inside them across immense stretches of time. If confirmed, those ice deposits could become one of the most valuable resources for future exploration. Water means drinking supplies. Water means oxygen. Water means rocket fuel. In many ways, water could determine whether long-term human activity on the moon becomes practical. But these permanently shadowed regions also create new mysteries. Scientists are studying environments unlike anything humans have ever explored directly. Places frozen in darkness for geological ages. Places preserving records from the earliest history of the solar system. Places that may contain answers to questions we have not even thought to ask yet. And that is exactly why the Artemis program matters. It is not simply about returning to the moon. It is about investigating a world that remains surprisingly unknown. A world that still hides secrets beneath its surface. A world where every new mission seems to uncover another mystery. And as researchers continued analyzing data connected to the far side and the lunar South Pole, they began noticing discoveries that would make the moon seem stranger than ever before. Because some of the most surprising findings were not coming from the surface. They were coming from deep below it. For a long time, scientists viewed the moon as a relatively simple world. Unlike Earth, it has no oceans, no weather, no moving tectonic plates, no forests, rivers, or active ecosystems constantly reshaping the landscape. Because of that, many researchers assumed that the moon's interior had become quiet billions of years ago, a frozen relic from the early solar system. But modern observations have challenged that assumption. As new missions gathered increasingly detailed information, evidence began emerging that the moon may have a far more complicated internal history than previously believed. One of the biggest surprises came from gravity measurements. At first glance, gravity might seem unrelated to hidden lunar mysteries, but gravity can reveal what lies beneath the surface. When spacecraft orbit a planetary body, even tiny variations in mass can affect their trajectories. By carefully tracking those changes, scientists can create maps showing regions where underground material is denser or lighter than expected. And that is exactly what happened on the moon. Researchers discovered areas where gravity behaved in unusual ways. Some regions appeared to contain massive concentrations of dense material buried below the surface. These hidden structures became known as mass concentrations, or mascons. The discovery was surprising enough on its own, but what made it even more fascinating was their size. Some of these underground structures are enormous. They influence spacecraft orbits and reveal clues about events that occurred billions of years ago. Scientists believe many mascons formed when gigantic asteroids slammed into the moon during its violent early history. The impacts created vast basins. Later, molten material filled portions of those basins, creating dense underground regions that still affect gravity today. Yet not every observation fits perfectly into existing models. Some measurements continue to generate debate. Some structures appear more complex than expected, and researchers are still working to fully understand how certain regions evolved over time. The far side of the moon has become especially important in that investigation, because unlike the Earth-facing side, it preserves a very different geological record. It is almost like comparing two separate worlds. One side contains large dark plains known as maria. The other side is dominated by ancient highlands and massive crater fields. The contrast is dramatic, and scientists still do not have complete answers for why those differences exist. One possibility involves heat. Billions of years ago, radioactive elements inside the moon may have been distributed unevenly. Some regions may have retained more internal heat than others. That heat could have influenced volcanic activity, crust thickness, and geological evolution. If true, it would mean that the moon's history was far more dynamic than once believed. As Artemis-related research expanded, scientists began combining data from multiple missions. The goal was simple: build the most complete picture of the moon ever assembled. What emerged was a world filled with unanswered questions. Questions about its formation, questions about its interior, questions about what may still remain hidden beneath its surface. One particularly intriguing discovery involves the moon's crust. Researchers now know that crust thickness varies significantly across different regions. In some places, it is much thicker than expected. In others, surprisingly thin. That variation affects everything from impact formation to volcanic history. It also affects where future missions may choose to explore, because every layer of lunar rock preserves evidence from a different chapter of the moon's past. And those chapters stretch back more than 4 billion years. To put that into perspective, many lunar rocks formed before complex life appeared on Earth. Some are older than nearly every geological feature that exists on our planet today. The moon is essentially a time capsule, a preserved record of the early solar system. That is one reason scientists are so eager to study the far side. Unlike Earth, where erosion constantly destroys ancient evidence, the moon preserves its history with extraordinary detail. Ancient impacts remain visible. Old geological structures survive. Features that vanished long ago on Earth can still be found on the lunar surface. But perhaps the most fascinating mystery involves what researchers call lunar anomalies. These are locations where observations do not perfectly match expectations. Sometimes magnetic fields appear where they should not. Sometimes underground structures seem unusually complex. Sometimes mineral distributions challenge existing theories. None of these discoveries mean something supernatural is happening. In fact, the real science is often far more interesting, because every anomaly represents a puzzle waiting to be solved. A clue pointing toward a deeper understanding of how the moon evolved. One example involves localized magnetic regions. The moon does not possess a global magnetic field like Earth, yet certain areas contain surprisingly strong magnetic signatures. Scientists believe these may be remnants from an ancient period when the moon's interior behaved very differently. If that theory is correct, the moon may once have generated a magnetic field far stronger than the one observed today. That possibility completely changes how researchers think about its early history. It suggests a more active interior, a more energetic past, a more complex world, and every new piece of evidence seems to point in that direction. Meanwhile, researchers studying permanently shadowed craters near the lunar South Pole have uncovered another challenge. Many of these regions remain difficult to observe directly. Sunlight never reaches portions of their interiors. Temperatures are so low that equipment must operate under extreme conditions. Communication can also become difficult depending on location. Yet those same conditions make the craters scientifically priceless. Anything trapped there may have remained preserved for billions of years. Ice, dust, ancient particles from comets, material from the earliest days of the solar system. In some ways, these craters function like natural vaults. They store records from a time before Earth looked anything like it does today. That is why future Artemis missions are expected to focus heavily on the lunar South Pole. Scientists want samples. They want measurements. They want direct access to regions that have never been explored by humans. Because every answer seems to generate new questions, and those questions are becoming increasingly difficult to ignore. How much water actually exists there? What secrets are preserved inside permanently shadowed craters? What lies beneath the strange structures detected deep underground? And perhaps most importantly, what else has remained hidden simply because nobody has looked closely enough? The moon spent centuries appearing familiar, a bright object hanging in the night sky, a destination humanity visited and then left behind. But now, as Artemis pushes exploration into a new era, researchers are realizing that our nearest neighbor may be far stranger than anyone imagined. And some of the most surprising discoveries are connected to a region that could become the center of humanity's future beyond Earth. A place where darkness lasts for billions of years. A place where ancient secrets remain frozen in time. A place that may hold clues not only about the moon's history, but about the origins of the entire solar system. And what scientists discovered there next would make the mission even more important. As scientists looked deeper into the moon's south polar region, they began realizing that this area is unlike any other place humans have ever attempted to explore. From orbit, the landscape appears rugged and ancient. Towering crater walls cast enormous shadows across the surface. Deep valleys cut through the terrain. And in some locations, sunlight barely reaches the ground at all. At first, these features were viewed primarily as engineering challenges. Future astronauts would need to navigate difficult terrain. Equipment would need to survive extreme temperature changes. Communication systems would need to operate in regions where direct contact with Earth might not always be possible. But the more researchers studied the area, the more they realized that these challenges existed alongside extraordinary scientific opportunities. One reason is the age of the terrain itself. Many regions near the lunar South Pole are believed to be among the oldest surfaces on the moon. Some have remained relatively unchanged for billions of years. That means they preserve evidence from an era when the solar system was still young, an era marked by violent collisions and planetary formation. Every crater tells part of that story. Every layer of rock contains clues, and every sample collected could help scientists reconstruct events that occurred long before Earth became the world we know today. This is one of the reasons Artemis has generated so much excitement among researchers. The mission is not simply about reaching the moon. It is about accessing a scientific archive that has remained largely untouched. A record of cosmic history preserved in stone. But one discovery has attracted particular attention. Scientists studying permanently shadowed regions have found increasing evidence that water ice may be far more widespread than once believed. That matters because water changes everything. For future explorers, water could become one of the most valuable resources available. Instead of transporting every drop from Earth, astronauts may eventually be able to use local supplies. Water can support life. It can be converted into breathable oxygen. It can even be separated into hydrogen and oxygen for rocket fuel. In other words, water could help transform the moon from a destination into a stepping stone, a base for deeper exploration of the solar system. But locating water is only part of the challenge. Scientists still need to understand how much exists, where it is concentrated, how easily it can be extracted, and how long it has remained there. Those questions have driven years of research. Yet each new study seems to reveal additional complexity. Some models suggest ice may exist in thin layers mixed with lunar soil. Others indicate that larger deposits could be hidden within permanently shadowed craters. Researchers continue to debate the details. What they agree on is that the moon is revealing far more complexity than earlier generations expected, and that complexity extends beyond water. Another major focus involves understanding how the moon formed in the first place. The leading theory suggests that billions of years ago, a Mars-sized object collided with the young Earth. The impact was catastrophic. Enormous amounts of material were blasted into space. Over time, that debris came together and formed the moon. It is one of the most dramatic events ever proposed in planetary science. Yet despite decades of research, many details remain uncertain. Scientists still want better evidence. Better samples, better measurements, and that is where the far side becomes incredibly important, because different regions preserve different chapters of lunar history. Some areas may contain information that helps explain conditions during the moon's earliest stages. Others may reveal how its interior evolved over billions of years. The more scientists learn, the clearer it becomes that the moon's story is deeply connected to Earth's own history. Without the moon, our planet might look completely different today. The moon influences tides. It stabilizes Earth's rotational tilt. It has affected our planet for billions of years. Understanding its origins helps us understand our own. That alone would make Artemis one of the most important scientific programs of the century. But there is another reason researchers are paying close attention. The far side of the moon offers something unique that cannot easily be found anywhere else near Earth. Silence. Not silence in the ordinary sense. Radio silence. On Earth, countless signals constantly fill the air. Television broadcasts, cell phone networks, satellites, radar systems. Every day, our planet generates an ocean of radio noise. For astronomers, that creates a problem. Certain observations become extremely difficult when those signals interfere with sensitive instruments. The far side of the moon provides a solution, because the moon itself blocks much of Earth's radio interference. Scientists have described portions of the far side as one of the quietest radio environments in the inner solar system. That makes it potentially ideal for future observatories. Imagine enormous radio telescopes operating from a location naturally shielded from Earth's noise. Such facilities could study distant galaxies, ancient cosmic signals, and phenomena that are difficult to observe from our planet. Some researchers believe the far side could become one of the most important scientific locations in human history, a place where entirely new discoveries become possible. And that possibility has added even greater significance to Artemis-era exploration. Because before any future observatories can be built, scientists need detailed information about the environment. They need maps, measurements, data about terrain, radiation, dust, and resources. Every mission helps fill those gaps. Every observation expands humanity's understanding. And every discovery makes the moon seem less like a familiar neighbor and more like an unexplored frontier. What surprises many people is how much remains unknown. After all, humans first reached the moon in 1969. More than half a century has passed, yet enormous portions of its history remain unresolved. Scientists continue debating major questions. They continue refining theories. They continue uncovering evidence that challenges earlier assumptions. The moon is not a solved mystery. It is an active field of research. And perhaps that is the most fascinating revelation of all. The object that hangs above Earth almost every night still has secrets to reveal. Secrets hidden in shadowed craters, secrets buried beneath ancient rock, secrets preserved from the dawn of the solar system. As Artemis moves humanity back toward the moon, those secrets are finally coming into focus. But the biggest question may not be what scientists have already discovered. The biggest question is what they have not found yet. Because if recent discoveries have taught researchers anything, it is that the moon has a remarkable ability to surprise us. And the next phase of exploration could uncover findings that change our understanding of both the moon and Earth forever. What comes next may be the most important chapter in lunar exploration since the Apollo era ended. As humanity prepares for a new age of lunar exploration, one reality is becoming impossible to ignore. The moon is not merely a destination, it is a gateway. For decades, space agencies dreamed about sending humans deeper into the solar system, missions to Mars, permanent space habitats, long-term exploration beyond Earth. But every one of those ambitions faces the same challenge: distance. The farther humans travel from Earth, the more difficult everything becomes. Fuel becomes a problem. Supplies become a problem. Communication becomes a problem. Survival itself becomes a problem. That is why the moon matters so much. Located only a few days away, it provides an opportunity to test technologies, develop new systems, and learn how humans can operate in deep space for extended periods. In many ways, Artemis is not just a lunar program. It is preparation for humanity's future beyond the moon, and that future depends on understanding the environment we are about to enter. The discoveries connected to the far side and the lunar South Pole are helping researchers do exactly that. Every new map reveals details that were previously unknown. Every measurement improves scientific models. Every mission adds another piece to a puzzle that scientists have been trying to solve for generations. Yet perhaps the most remarkable lesson from Artemis-era research is how much remains unexplored. Many people assume the moon has already been thoroughly investigated. The reality is very different. Only a tiny portion of its surface has ever been visited directly by humans. Vast regions remain untouched. Entire landscapes have never experienced a human footprint. Countless samples have never been collected. Countless questions remain unanswered. That realization has transformed how scientists view the moon. What once seemed like a familiar world now appears filled with opportunities for discovery. The far side alone contains geological features unlike those found anywhere else. Ancient impact structures, unusual mineral deposits, regions that preserve evidence from the earliest history of the solar system. Each one has the potential to reveal something important, something unexpected, something capable of reshaping scientific understanding. And history suggests that surprises are almost guaranteed. Again and again, Exploration has shown that nature is more creative than human imagination. Researchers develop theories. Observations challenge those theories. New evidence emerges. Understanding evolves. The moon has followed that pattern for decades. Every major advance has generated new mysteries. Every answer has led to additional questions. The discovery of the far side revealed an entirely different landscape. Gravity studies uncovered hidden underground structures. Modern instruments detected evidence of water ice. Advanced measurements exposed geological complexities that earlier generations never suspected. Each discovery expanded humanity's understanding, and each one demonstrated that the moon still has stories left to tell. That is why missions like Artemis II are so important. They represent more than technological achievement. They represent curiosity, the desire to explore, the willingness to investigate places that remain unknown. For thousands of years, humans looked at the moon and wondered what was there. Now, for the first time in generations, we are preparing to return with capabilities far beyond anything available during the Apollo era. More advanced spacecraft, more sophisticated instruments, more ambitious goals, and perhaps most importantly, a long-term commitment to exploration. The objective is no longer a brief visit. The objective is sustained discovery, to learn, to build, to prepare for the future. Scientists hope that future Artemis missions will answer some of the biggest questions surrounding the moon. How much water exists near the poles? What can ancient lunar rocks reveal about the formation of Earth? How did the moon's interior evolve? What lies beneath the strange structures detected by modern instruments? Can lunar resources support long-term human activity? And what other surprises remain hidden beyond the next crater wall? Those questions drive research across the world, because the answers affect far more than lunar science. They influence our understanding of planetary formation, solar system history, human exploration, and potentially the future of civilization beyond Earth. The moon may be close compared to other worlds, but in many respects, it remains a frontier, a place where discovery still waits, a place where mysteries still survive, a place where the next breakthrough may arrive at any moment. And perhaps that is the true meaning behind the phrase, "The moon was hiding this." Not a monster, not an alien structure, not a supernatural secret, something far more fascinating. Knowledge. The realization that even our closest celestial neighbor contains mysteries that science is only beginning to understand. The hidden side of the moon spent centuries beyond human sight. Today, advanced technology is finally revealing its secrets. Yet the more scientists learn, the more they recognize how much remains unknown. That may be the most surprising discovery of all. The moon is not becoming less mysterious. It is becoming more mysterious. Every new mission uncovers details that raise deeper questions. Every new observation reveals complexities that demand further investigation. And every step toward understanding opens the door to even greater discoveries. Artemis II represents another step in that journey. A journey that began when ancient people first looked toward the night sky and wondered what existed beyond Earth. A journey continued by astronomers, engineers, scientists, and explorers across generations. And a journey that is far from over. Because somewhere beyond the familiar face of the moon lies a landscape that still holds unanswered questions. Questions preserved for billions of years. Questions waiting for future explorers. Questions that may help explain how our solar system formed, how Earth evolved, and where humanity goes next. The moon's hidden side is no longer completely hidden, but its greatest secrets may still be waiting to be discovered. And that is exactly why the world is watching, because the next chapter of lunar exploration has only just begun, and nobody can say for certain what humanity will find there next.